Hey AP Calc students, time to look at another FRQ from an old AP exam. This time we're going to be looking at the year 2013, question number 1 on the AP Calc AB exam. Now this type of question, first it's a calculator question because it is question number 1, but this falls into the category of what I like to call two rates. And what you get is a rate something is increasing, or we say a rate in, and then also a rate out, or a rate that the situation's decreasing. And it doesn't really matter what the actual context of the question is. There's going to be something that's increasing, something that's decreasing, and typically when the day begins or the time period begins, there was an amount of product or whatever the question is dealing with present. So let's read this one and then we will dive in. Here we go. So it says, on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of t is equal to 90 plus 45 cosine of t squared over 18, where t is measured in hours and 0 less than or equal to t less than or equal to 8. At the beginning of the workday, t equals 0, the plant has 500 tons of unprocessed gravel during the hours of operation. 0 less than or equal to t less than or equal to 8. The plant processes gravel at a constant rate of 100 tons per hour. So it looks like we have a gravel plant, and trucks are showing up all day for the 8 hours, and they're showing up at a rate not unusual. They like to put sinusoidals in here so that the rate the gravel is showing up is oscillating, and so sometimes it's increasing, sometimes it's decreasing, it just depends. And then it looks like the gravel is actually being processed at a constant rate, it says, of 100 tons per hour. So the rate in, the G function here, the rate out, or the rate being processed, it's a constant. And then it says when the day begins, t equals 0, it's 500. So we have quite a bit of information, and this is very straightforward for a two-rate type of question. So let's see what we've got. Question A. A says, find G prime of 5, and then using correct units, interpret your answer in the context of the question. Well, first, G prime of 5 should be pretty easy if you know how to take a derivative. It's a fairly straightforward process here. But first, let's just recopy here G of t. And so I'm going to rewrite G of t is equal to 90 plus 45 cosine of t squared over 18. Well, since this is a calculator question, we could just put this into our calculator, take the derivative of this, evaluate it at 5. But I'm going to go ahead and write what G prime of t is equal to. So the derivative of 90 is 0. Derivative of 45 cosine is going to be negative 45 sine of this angle, t squared over 18. And then we'll have to multiply by the derivative of the angle, which would be 2t over 18, or t over 9. So that would be our derivative, and then it wants us to evaluate that at 5. We have G prime of 5, we could evaluate it into the function here, but I'm actually going to throw this into the calculator and evaluate it at 5. That's what would really be intended in this question. So if I go under my math menu and I go down to number 8, there's the notation there for the derivative. And so d dx, and I'm going to put in the original g function, which is 90 plus 45 cosine of t squared divided by 18. And that's actually the function. They want us to evaluate that at 5. Taking advantage of technology here, we get negative 24.5875. We'll round that up to negative 24.588. And then we're going to have to label this and explain exactly what we did here. Now let's look at what G actually is. G is the rate that the gravel is showing up. So G prime is the rate of the rate. So whenever you take the rate of a rate, you have to be careful with your units of time, so that the rate the gravel is showing up is, first off, the rate is negative, so it must be decreasing, and it's the rate of a rate. This is tons, and the time unit here, it says here this is measured in hours. It's ton per hour, or we can just say tons per hour squared. Now it says find G prime of 5 using correct units. We did that. Then also interpret this in the context of the problem. Well, in the context of the problem, what this tells me is that the rate the gravel is arriving is, now, whenever you take a derivative, when your derivatives are negative, that's telling you that the original function is decreasing. Well, just because my original function already is a rate, it doesn't change that rule. So what this means is the rate the gravel is arriving is decreasing at this rate. So the rate the gravel is arriving is decreasing, and we know that because the derivative is negative. So that's the really important part, and it's decreasing at a rate of, and we actually wrote that down, but I'll write it down again, it's decreasing at a rate of negative 24.588 tons per hour squared. Technically per hour. And that's part A. Let's move on. Part B. Part B says, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation of this workday. Well, a very important concept whenever you're doing calculus is, what do you get when you integrate a rate? And it's whatever the rate produces. So if this is asking me how much, find the total amount of unprocessed gravel that arrives, if I have the rate the gravel is arriving, I can just integrate that, and I'll get how much gravel arrived. So it says during the workday. Well, it doesn't get much easier than this. Very straightforward. We're going to integrate from 0 to 8 the function of the gravel arriving, which is just g of t. And this is a total calculator question. And all we have to do is go ahead and take advantage of the calculator. And I'm going to go to my integral now, and I'm just going to integrate from 0 to 8 the same function I took the derivative of before. So I'm integrating 90 plus 45 cosine of x, or t squared x squared over 18. And my variable of integration is x. And it looks like my answer is 825.551 tons. You integrate the rate to get what the rate produces. So I integrated the rate the gravel was arriving, and I got how much gravel arrived, 825.551 tons. There's part B. Let's continue. Part C. Part C says, is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5 hours? Show the work that leads to your answer. Now I'm going to do this two ways. One, you can choose whichever way you prefer, but you're going to see why I'm doing a rather simple way, and then I'll do a more sophisticated way. Well, here's the simple way. If you want to know what's going on at t equals 5, well, then just substitute it into the functions that are given and see. So I'm kind of curious, what is happening at g of 5? So if I substitute 5 into the function, I'm going to take advantage of my calculator one more time here, and I'm going to say, well, it looks like at hour 5, if I take 90 plus 45 cosine of 25 divided by 18, I get 98.141. 98.141, and that would be tons per hour. So it looks like at time t equals 5, there's 98.141 tons per hour of gravel showing up. Well, what also happens, they don't actually label this function, but I'm just going to say processed. The amount that's processed at t equals 5 would be 100 tons per hour. Now, the reason we know that is it's given in the question. So if you look up here, it says the plant processes gravel at a constant rate at 100 tons per hour here. And so that's what I have. So the question says, is the amount of unprocessed gravel at the plant increasing or decreasing at t equals 5? Show the work that leads to your answer. Well, it looks like we're processing more than is showing up. Well, if you process more than is showing up, then the amount of gravel at t equals 5 must be decreasing. And so we're going to say decreasing because the amount being processed is greater than the amount arriving. And we have it right there, 100 tons per hour versus 98. That's one way to do the problem. But I'm going to do this slightly different. The alternate method is, whenever you hear, is the amount of unprocessed gravel at the plant increasing or decreasing, when you hear the term increasing or decreasing and you want to know whether a function's increasing or decreasing, you should probably be thinking of finding a function and taking its derivative, because derivatives being positive or negative tells us about increasing or decreasing. Instead of doing this is building a function that represents how much gravel is at the plant at any given time. And this is a fairly common approach for AP questions that have to do with having multiple rates. And so what I'm going to do is build a function that represents how much gravel is at the plant at any given time. So what I'm going to say is A of t is equal to three things. The first thing is how much gravel was there, or how much of the substance was there when the day began. I'm going to add to it the increase is the second thing, and then I'm going to subtract how much was taken away as the day began. So the amount is always equal to three things: the day beginning, the amount of increase, minus what was taken away. So I'm going to change this a little bit. I'm going to replace these with words and symbols. So the first thing is the initial amount that was there when the day began. I'm going to add to that the integral from 0 to t of whatever function is representing the increase. And then I'm going to subtract from that the integral from 0 to t, whatever represents the decrease. Now this will work for any type of rate question, because there's always a rate that something's increasing, a rate it's decreasing, and how much was there when the day began. So I'm going to use this concept here and build a function, specifically for the one we're doing. So a sub t equals, well, let's read the question and see how much was there when the day began. Here toward the second part of the question it says the plant has 500 tons of unprocessed gravel at t equals 0. So at the beginning of the day there's 500, that's our initial amount. Plus, we need to integrate how much arrives. So it says on a certain work day, there's the amount that arrives is modeled by g of t. So from 0 to t, g of t is the amount that arrives. And when you want to know how much arrived, you integrate the rate it was arriving. We actually did this part over here in part B. So it's 500 plus the amount that arrived, and then I'm going to subtract how much was taken away. Now the rate of how much was taken away is a constant. It says 100. And there it would be. Now, there's a couple things that come up when you build this. Now, I intentionally right here, I have a little error. It's a very easy mistake to make that some students do, and they don't really get penalized for it. But if you do not know what your variable is on your interval, then you can't use the same variable in your integral. And so the fact that I don't know this t, and this is what I'm building, the a of t, this cannot be also t's in my integral. So what I need to do is change that to another variable, and I'm just going to change it to x. It does not make mathematical sense for your interval variable to be the same as your integral variable. These have to be different, and I'm trying to figure out time, so a of t is actually my interval value after I integrate. Then over here it's the same thing. This can't be a dt, this has to be a dx. So sometimes you get penalized for that, sometimes not, but it's an important little thing to catch. So this is the function that represents how much gravel is at the plant at any given time. Well, again, back to part C, it says find is the amount increasing or decreasing. Well, if you want to know increasing or decreasing, you take a derivative, get your critical points, and test your intervals. So what I'm going to do now is find a prime. So a prime of t is equal to, and I'm going to take the derivative of this. Now, the derivative of 500 is 0. The derivative of an integral, if you recall the second fundamental theorem of calculus, I'm going to take the derivative of this whole thing. Now I'm going to be extra specific on how this actually works on this one. It simplifies very nicely, but there's actually 4 things to consider, and I'm going to write all 4 down. It's easy to make a mistake here. Because I'm taking the derivative of an integral, you can think of those as canceling, but because my interval is varying, I have to do the fundamental theorem, replacing my variable with my interval values. So technically, this becomes the derivative of the integral with the fundamental theorem is going to be g of t times the derivative of the interval value, which is 1, minus g of 0 times the derivative of 0, which is 0. Technically, I had to do all 4 of those components to take the derivative of this integral. Minus, this is also the same. So I evaluate the function at t, and that is just 100, times the derivative of the interval, which is 1, minus the function evaluated at 0 is still going to be 100, times the derivative of 0, which is 0. Technically, that's what I get, all four components. If I simplify all that down, the derivative is simply a prime of t is equal to, all of this simplifies down to just g of t minus 100. Now, what the question asks for, what's happening at at t equals 5? Well, then I would say, well, a prime of 5 is equal to, well, I would just find g of 5, which I actually did. It's right here. I'm going to replace that. I'll actually write g of 5 here, minus 100. And that was equal to 98.141 minus 100. And what I wind up with is going to be, what do we get here? Negative 1.159. So at a prime of 5, I get a negative number. And since I get a negative number, that tells me that it's decreasing. That would be another way to do this problem. So I could have said just over here, do g of 5, compare it to 100, or I could have built the function, took its derivative, and then evaluated at 5. But in both cases, it's the value here is negative because it's decreasing. Now, the reason I showed this is a very common process that comes up, and as we do part D, it's going to come in very handy. D says, what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Justify your answer. Well, whenever you want to find maximums, you need critical numbers. And you also want to check your endpoints. Well, as it turns out, in order to find, I need to build a function for how much gravel is at the plant at any given time, and then I need to take the derivative, and then I need to find a maximum. Well, that's what all of this work was up here. So what I'm actually going to do is go back to this function right here, a prime of t. There's my derivative, and I'm going to set it equal to 0 and undefined, and get my critical numbers. So I'm going to borrow that value right there, and I'm going to say, well, a prime of t is equal to g of t minus 100. I'm going to set that equal to being undefined, and I'm going to set that equal to 0, and I'm going to get some critical numbers. So g of t, again, is this over here. If you guys can imagine this function right here, 90 plus 45 cosine of t minus 100, what that's going to wind up equaling really is 45 cosine of t squared over 18 minus 10, because of the 90 minus 10. So that's actually the function that I'm setting equal to undefined, and I'm setting it equal to 0. Well, this function, you guys, that's a cosine graph. That's never undefined. And then when is it equal to 0? We again could graph this on our calculator and get our values. So if I graph this function on the calculator again, I'll take advantage of just looking at that on the graph. And I'm going to go to y equals here. We're all cleared out. And I'm going to say, all right, 45 cosine of x squared divided by 18. And then I'm going to subtract 10. And I'm curious what this looks like. And I'm just going to go zoom standard here. And you can see, because it's a cosine function, you're going to see that what appears to be this oscillation. But the thing you want to keep in mind whenever you have this kind of question is respect what the domain is, and so, or the range. And on this question, the t values go from 0 to 8, which would correspond to the domain for this problem. So we're done graphing, and I can see how high this is going, but what I'm wondering is when is this equal to 0? So even though this looks like it's oscillating, I don't really care about these high points on here. I'm going to go to my window, and I'm going to say, well, I just really care about going from 0 to 8. And maybe just for the heck of it, these y maxes and mins, maybe I'll see if I can catch them if my y max is 50 and negative 50. I'll just throw those in there for fun. I don't really care what they are. But now here's from 0 to 8. And there is the only 0 in the interval. And so I'd have to find that value. And so I'm going to find my 0. And that's good enough. And now get to the other side, and that's good enough. And let's see what the calculator says. 4.923. All right, so that's my only critical number. And then I also have to check my endpoints, because it said it wants to know what the absolute, what's the maximum during the hours of operation. So what I would like to check is, I'm curious what's happening at the beginning of the day, A of 0. I also want to know what's happening at 4.923. And I'm also curious what's happening at the end of the day. And we're going to check those three values and see which one's the highest. Now, if you wanted, you could do an interval test with 4.9 and see where it's increasing and decreasing. Not really necessary. So on this one, because we only have three values to check, the beginning of the day, we already know it says at the beginning of the day there's 500 tons of gravel at the plant. Now to figure out, back up here, we need to figure out how much is at the plant when there's 4.923, and also compare how much is there at 8. So I'm going to quit out of here, and I believe I'm going to go up here, and I'm going to hit enter, and I'm going to recopy that so I can edit it. So what I need is, I need to go, I'm going to do this one first because I already have 0 to 8 up there. So I integrated from 0 to 8, the g function. So everyone, what I'm looking at right here is I'm performing a of t with right up here, this equation right here. Okay, so I'll go ahead and rewrite it again up here. A of t is equal to 500 plus the integral from 0 to t of g of x dx minus the integral of 0 to t of 100 dx. Okay, now if you wanted, you could put that in one integral, and in fact that's what I'm going to do for this one. That's how I want to edit this. So I'm going to integrate from 0 to 8, which I already have, but I'm going to backtrack here and I'm going to insert there, putting minus 100. So I'm going to do minus 100. I already have that now in that integral, and then the result of that I'm going to add 500 to. So I've got everything I need, and then after it's all over, I'll add a 500 to it, and let's see what we get. All right, it looks like we get 525.551. Okay, so by the end of the day, we have a little bit more than we started with. And now what I'm going to do is go back up to here, take advantage of it. I'm just going to enter, and I'm going to edit this question. It's the exact same question, and this saves you so much time when you do this. And all I need to do now is I need to go up here and replace the 8 with a 4.923 instead of doing all that typing. 4.923. Got all of that in there. And now let's see what happens at that point of the day. 635.376. And all of these are tons. So the question was, at what day do we have a maximum? And it looks like that occurs at this step right here. And so we can say maximum amount of unprocessed gravel occurs at t equals 4.923 and 635.376 tons. There we go. Calc AB 2013, number 1. See you next time for more questions. Thanks.